All right, chapter 6, lesson 3, still talking about transformations. This time we're going about rotations. So I would say out of all of the transformations, this is probably my least favorite, only because I know it gives kids problems, especially if you're not a very visual person. So sometimes whenever I say during this lesson, it's almost like you're standing on your head, or if you turn your head or cock your head to the side, you know, like whenever you talk to your dog and he doesn't really understand what you're saying and he's like, huh? To the side. What, your dog doesn't make that noise? You must have a weird dog. Anyway, back to the subject. Let's talk about rotating a figure. So a rotation is like a turn. So if you rotate something, it means you turn it around. Depending on how many degrees it's rotated, depends on how many turns you make it. All right. So let's talk about number of turns, first of all. And whenever I say clockwise, counterclockwise, and so forth. So whenever I'm saying turn something clockwise. So if this is a clock, 12, 1, 2, oops, that's a 2, 3, 4, 5, 6, and on around. So if I'm talking about clockwise, I'm talking about something that turns this way, because that's how a clock will turn, and it will go this way. Okay? So that is clockwise. If you think you might need to write that down, I would go ahead and do so. So that is clockwise. Now, if you go in the opposite direction, like if you were turning back the hands of time, then that is talking about going counterclockwise. That would be going backwards. All right? So clockwise, turn it to the right and down. Counterclockwise, turn it to the left and backwards. Now, when we start talking about degrees, any of you who do any kind of skateboarding whatsoever, you know that a full rotation, 360 degrees, right? Means you're headed back in the same direction you were. So really, if you do a 360, means you turn around, but really nothing's changed because you're still heading in the same direction. If you do a 180, 180 means that, okay, let's say you were facing this way. 180 means you're going to go halfway back around, and now you're just going to be turned the other way. So whenever you talk about things like this, you can talk about a full turn would be 360. Half of a turn, 1/2 of a full turn would be 180. Or you could talk about just a fourth of the way would be a 90-degree turn. A fourth of the way would be a 90-degree turn. So some people would rather just talk about 90-degree turns because that means you either turn left or right. So if you want to talk about this, a 90-degree turn would be one turn to the right. Now you're facing this way. Another 90-degree turn would be one more to the right. Now you're facing this way, right? That's two 90-degree turns would be a 180. So you could talk about 2 turns. Or if you talk about, obviously a 90 would just be 1, but if you talk about like a 360, that would be 4 turns. 360 is 4 turns. Or even sometimes they may talk about a 270, which means you're going to turn right, you're going to turn right, you're going to turn right. 390s is a 270. So you could even talk about like a 270 being 3 turns. So it's really however you want to talk about it, and we'll maybe make more sense as we do it. All right? So that's just some background information that I know you need to know. So let's look at triangle LMN. That would be the blue one, because remember it does not have these little prime marks, so this is the original one. LMN, these 3 vertices right here, represents a desk in Jackson's bedroom. He wants to rotate the desk counterclockwise, which means he wants to rotate it this way. Counterclockwise, going to the left. 180-degree turn. So that means it's really 2 90-degree turns. So you want to turn it left once and then turn it left again. So graph the figure and its image. So here's something that I want you to think about. If it says about vertex L, basically means this corner of his desk stays exactly where it is. You remember those little pinwheels whenever you were little and they looked kind of like this? Right? Those little pinwheels that you would blow and then they would turn around like on a stick. Woo! That's what we got here. So whenever things turn, about a point. That point is called its center of rotation. That point is fixed. Fixed means it does not move. So you are going to turn it once. If you turn it once, this side LM, you see how it's 1, 2, 3 units long? It would be 1, 2, 3 units long. And it is 1, 2, 3 units tall. 1, 2, 3 units tall. So it would kind of look like that if you only turned it 80 degrees. Sorry, 90 degrees. But we don't want it turned 90 degrees. We want to turn it one more time. So again, this point L stays the same. This moves down here. Again, if it's 1, 2, 3 units, it's going to be 1, 2, 3 units. This way, 1, 2, 3 units. 1, 2, 3 units. That gets you how far it is out and how far it is away. Then you can simply connect it back here. Okay, so sometimes whenever the number here is bigger than 90, it helps you to draw the intermediate one in the middle. So that way you can better gauge where it is. Now, this is not how the book teaches you to do it. They talk to you about using a protractor measuring 180 degrees, which is fine, but if they do more than 180, if they do 270, sometimes that gets a little messy. But feel free to do that. They're talking about this angle right here, 180, basically means that they want the line to continue. And then you can measure out how far out this is 3 units, how far out this is 3 units. This is 3 units up. That means this has to be 3 units up, but in the opposite direction. That's what a 180 is, in the opposite direction. Okay? And so then the points, let me get back to this. Then the points, right down here. L prime, 5, 4, M prime, 5, 1, and N prime, N 1. All right. Let's see how you do on one. Come on. All right, I want you to pause it and try got it. This one's a rectangle, but I think you'll be okay. All right, rectangle ABCD with vertices at negative 7, 4. That would be at negative 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Negative 7, 4. That is A. B, negative 7, 1. C, negative 2, 1. Better mark that as B and C. And D, negative 2, 4. That's D. All right, so there's your rectangle. So, got it graphed first. All right, now it says, this is the bed in Jackson's room. Graph the figure and his image after a clockwise rotation of 90 degrees. So, clockwise means that you're going to be going this way. And it's 90 degrees, so that's one turn, about vertex C, which means C stays the same. So think of it like you're taking his bed and standing it up this way. Taking this and standing it up this way. So if C is going to stay the same, and you know that D is 1, 2, 3 units out, then this is going to be 1, 2, 3 units out. This is the new D prime. Now, that you know the base of the bed here, you should be able to figure out, okay, from D to A was 1, 2, 3, 4, 5 units. So D to A has to be 1, 2, 3, 4, 5 units. Be A prime. B is 1, 2, 3, 4, 5 units up from C. 1, 2, 3, 4, 5 units up from C. And of course, C didn't change, so that is also C prime. Then give the coordinates of these vertices. So A prime is 1, 2, 3, 4, 5, 6. So A prime is 1, 6. D prime, 1, 1. B prime, negative 2, 6. Go ahead and label these if you don't have the letter right next to it. And C prime did not move. So C is still going to be -2, 1. Okay. So this is where, like I said, rotation, sometimes you have to cock your head to the side, sometimes you have to turn and rotate your paper. Whatever you need to do, that's what I would do. All right, moving down. Let's talk about rotations about the origin. So until now, we've had one fixed point of the figure. Now they don't want you to have one fixed point of the figure. They want you to take the whole graph and move it. This would be a good time to turn your paper. If it's a rotation about a point, that would be a good time to just kind of cock your head to the side and see what it looks like. If it's a rotation of the paper, I would actually kind of, I don't know, pretend that this, let me see if I can do this, that this whole paper, let's say this right here is my whole graph paper. I want to show you a rotation about the origin, so a rotation about this center point right here. I can look and turn a 90-degree turn, see how it's turning around the middle. 90-degree turn clockwise would look just like that. So I'm just basically taking my whole sheet of paper, think about the whole red outside square being my whole sheet of paper, turn it, where would it be? That would be a 90 degrees clockwise rotation. Now, what if I wanted a 180 degrees clockwise rotation? So that's basically saying, okay, one 90-degree turn, two 90-degree turns. So it looks a little off the grid paper here, but this is exactly what it would look like, this green one right down here. That is 2. A 270 would be back in my starting position, right? So I would turn it, one turn would be 90, 2 turns would be 180, 3 turns. 3 turns would be 270. So if your brain can wrap around it, you can also think, okay, instead of going 3 turns this way, well, wouldn't it be the same if I just went 3 turns clockwise would be the same thing as 1 turn counterclockwise. So you can think about that as well if you wish. So I just want you to think about, know the difference between rotating around a point and rotating around the origin. So if you rotate around the origin, then that means the whole paper turns, kind of like a big pinwheel all the way around. If you rotate about a point, that point stays fixed. Okay? All right, let me get back to the start here. All right, so with that, let's get going on an example. All right, so before we go on to try one of these, let's talk about this transformation notation that we've got written up here. All right, so this is what we're talking about. If we're talking about a 90-degree rotation, 90-degree rotation, 1 turn to the right, that's what we just talked about whenever I was talking about flipping all the papers. So if you don't want to start flipping papers, maybe these formulas might be a little more use to you. So let's try this. This is saying that x, y, which you know x comes first, y comes second, but look, they actually flip places and you change the sign of the x. Let's look at that. B, right here, there's 1, 2, 3. So B is -3, 1. But in the new rotation, B prime, what is it? 1, 3. Notice that these switched places and the x changed signs. It was a negative and now it's positive. All right, let's try another one. C was -1, 1, 2, 3, 4, -1, 4. So our C prime, the x is going to change signs and it's going to go to the y position. So it should be 1, 4. Sorry, 4, 1. 4, 1. X is 4, y is 1. So that's what this talks about right here. So whenever you rotate, so you turn around the origin, 1 turn, what's going to happen is the y coordinate doesn't change except that it changes the x. X and y do a little flip-flop. Okay? But the x coordinate actually changes signs whenever it moves into the y position. Okay. If you do a 180 degree rotation, basically you're turning it twice. So not only does one of them switch signs, they both switch signs. They don't change places, however. They do not change places. So I would just say that x becomes a negative x, y becomes a negative y. All right? So it's the exact same thing, only for all you bikers and skateboarders, instead of heading this direction, you're now doing a complete 180, which means it's the exact same thing, only in the other direction. C is still up from A, 3 units, it's just going in the other direction. All right, and it turned around the origin. So if I look at the coordinates, let's say of B, B is 1, 2, 3, so negative 3, 1. Our B prime should be 3 and 1 in the same location, but different signs. So B prime should be 3, negative 1. Let's see if it is. 1, 2, 3, negative 1. 3, negative 1 is B prime. All right, so that is this one, 180 degrees, just the opposite of both. Now, we talked about a 270 degree rotation, and I talked to you about it being 1, 2, 3 turns, 3 90-degree turns, right? But I also talked to you, instead of just being 1, 2, 3, I also said you could do, it's like 1 90-degree turn counterclockwise. So think about that for just a minute. Whenever we did 1 90-degree turn clockwise, we changed positions and changed the x. So this time, if I'm going 1 90-degree turn the other way, to the left, I'm still changing positions, but this time I'm changing the sign of the y. Okay? So, again, let's talk about this. Let's do C. C used to be at negative 1, 1, 2, 3, 4. C used to be at negative 1, 4. So if I do 90 degrees, I'm only turning part of the way. I need to flip-flop my numbers, and my y changes signs. This was a negative 1. It's still going to stay a negative 1. Let's see if that's where it's at. C, is it at negative 4? 1, 2, 3, 4, down 1, and it is. All right? So if you are good with formulas, you may choose to memorize this part of it. If you are not good with formulas, don't use this way. Turn your paper, use your visual image, whatever you need to do. You know that if it is a 90-degree turn clockwise, instead of being one away on this side, it's going to be one away on this side. Then maybe you can just count. Okay, I know that B is 2 units left. If I turn my head, it's still going to be 2 units left. C is 2 units straight up from here. So, sorry, 3 units. So C is going to be 3 units straight up from here. I'm trying to give you multiple uses, multiple images, multiple methods. I'm going to ask you to choose the one that you think is best, whichever one works better for you. All right? So if you want to use the turn the paper trick, if you want to turn your head, if you want to use the formulas, whatever you want to do. Okay? If you're going to use formulas, though, you have to make sure 90 degrees you flip them, and 90 degrees clockwise you change the x, 90 degrees counterclockwise you change the y. All right? If it's 180, you keep them the same, but both of them flip signs. So again, if the whole flipping signs and changing locations confuses you, please, please, please do not do it. Okay? Please don't do it. All right. So let's talk about this one. Example 2, triangle DEF. Those are the vertices. Graph the figure and its image after a clockwise rotation of 90 degrees around the origin. 90 degrees around the origin. So that means each point is going to change. So I would usually pick the point that's closest to the origin. So this E closest to the origin, and I know that it is 2 units and 1 unit. So in order to get my new one, if I just happen to lay this down, think about laying this L down, it would now be 1 unit and 2 units. Hopefully you can see that I have turned this 90 degrees clockwise. All right, so this is my new E. From here, I know that I've got F is 1 unit down and 2 units to the left. So I know it's 1 unit down and 2 units to the left. My new F is right here. All right, and then from there, from F, I know I'm going to go 1 unit back, and it looks like, the lines are kind of faint here, but it looks like 3 units up. So 1 unit back and 3 units, 1, 2, 3, 3 units up. That is my new, that's D prime. That is my new triangle rotated about. All right? So again, if you're not a visual spatial person, this lesson might present some issues for you. Again, this is my least favorite one. I'm sure a lot of you are probably in the same boat with me. All right, so with that being said, let's try this. Last one. Try this one. Pause it. Try it. Please try it, because if you don't try it, you're really just cheating yourself. Okay, back with me. 2, 5. 2, 1, 2, 3, 4, 5. This is M. N, 6, 4. 2, 3, 4, 5, 6. 1, 2, 3, 4. P, 6, 1. And Q, 2, 1. Of course, they're not going to give you a nice, even anything to do, right? What shape is this, by the way? Only got 1 pair of parallel sides, 2 sides that are not. That would be a trapezoid. Yep, that's a trapezoid. Okay, so if you want to rotate it counterclockwise, which means this way, counterclockwise 270. Now, instead of doing something 3 times, wouldn't you rather just go 1 time in the opposite direction? So 270 counterclockwise is the same thing as doing 90 clockwise. 270 counterclockwise is the same thing as doing 90 clockwise. So, about the origin. Here's what I know. If this point is 1 up and 2 down, when I say down, I mean, how about this? 1 up and 2 over, then it's still going to be the same thing, only now it's going to be 1 over and 2 up. So I think let's label my points here. That's N, P, and Q. So this is point Q. Always start with the one closest to the origin. Closest to the origin. So this is Q, right? So if I turned this, then that means Q, turning my head, maybe cocking it to the right. Q, M used to be 1, 2, 3, 4 over. So this would be 1, 2, 3, 4. 1, 2, 3, oh, one more. 4 over. That is M prime. M prime. So let's try P, which was straight down from Q. P is straight down from Q, and it was 1, 2, 3, 4 over. So it's going to be 1, 2, 3, 4 over. That's P prime. So here's my quadrilateral so far. Okay, and now from P, N was 1, 2, 3. So it's going to be 1, 2, 3. And then I can just connect these two. That is my N prime. And it should make sense to you that if the slanted side was facing this way, 1 turn, the slanted side should now be facing down that way. So that is it. I would not go and do 3 turns to the left. I would just do 1 turn to the right. So this may present you with a few problems. If it does, come see me. You know I'm here to help. And as always, I wish you good luck.